we are on 10.2 telescoping series, example number 3. So let's go ahead and get started. To find out if the series converges, remember that we have to simply just take the limit as n approaches infinity of the sequence of partial sums. But first we have to figure out what in the world that is, because we have no idea right now. So recall that the sequence of partial sums is literally a sequence of partial sums. So it is the sum up until 1, and the sum up until 2, the sum up until 3, the sum up until 4, and so on. So what we need to do is figure out a way to get S sub n, but without getting like the whole entire thing. Like the pattern of telescoping series is that things will cancel out and you'll be left with a nice S sub n, which you can find the limit of easily. Because you don't want to take the limit as it approaches infinity of this whole entire thing. You don't have forever. So I like to do S sub 1 here on the side and S sub 2, and we'll go on from there. So S sub 1 is literally the sum up until 1. So you plug in 1. So that's cosine of 1 over 1, which is just cosine of 1. And then cosine of 1 plus 1, which is 2, over 1 plus 1, which is 2. And then I continue on with S sub 2, which is the sum up until 2. So that includes the sum of 1 plus the sum of when you plug in 2, so that is going to be cosine of 2 over 2 minus cosine of 3 over 2 plus 1 is 3. And then I'm going to do S sub 3, which is the sum up until 3, so that includes the sum of 2 plus whatever I get when I plug in 3 is cosine of 3 over 3 minus cosine of 3 plus 1, which is 4, over 3 plus 1, which is 4. And then I'm not going to do S sub 4, but you get the idea. So you could just do a few, and then you'll notice a pattern. The pattern is cosine of 1 is always there in each partial sum. What also is always there? Well, take a look at this. If I go here, this cancels out with this. And then if I go here, this cancels out with this. And then this cancels out with this. And so the whole idea is that in each partial sum, the last term is always what's left. And so your S sub n can be simplified to be cosine of 1, which is always going to be there. And then the last term. But the problem is the last term is different for every partial sum. So the question is, how can we come up with a formula that's going to represent the last term no matter what n is? So I can plug in, like, let's say S sub 100. When I plug in 100, I should get the last term at the 100th partial sum. So what is that going to be? Well, that's going to be this right here. This is the formula that represents the last term in every partial sum. The perfect example, this you get from here, and then this you get from here. This here is always going to give you the last term. All right, so then this is your simplified S sub n, and then you can go ahead and find the limit of that. So the limit as n approaches infinity of cosine of 1 minus cosine of n plus 1 over n plus 1 is what? Well, using your limit rules, you can just split this up. So this is just a constant, it's just a number, there's no variable in there, so that just becomes cosine of 1. And then this is where we use squeeze theorem. So squeeze theorem says, hey, just take this, put it in the middle, and then find two other thingy-majiggies that one is less than that and one is greater than that. And so you would use common sense. You're like, okay, what do I know about cosine? Well, I know that cosine anything is gonna have to be between -1 and 1. So what I'm going to do is I'm going to put -1 here and 1 here. And then I'm going to keep the same denominator. So the whole idea is that this is the least that it could be and this is the greatest that it can be. So this is true. This inequality is true. And then you can prove that if the limit of this one, if you take the limit as it approaches infinity of this, that really just becomes -1 over infinity plus 1, which is just infinity. That becomes 0. And if you can prove the same thing on the other side, 1 over infinity is 0. If these limits are the same, then you can for sure be rest assured that the limit of this one will also be 0. This is 0. So cosine of 1 minus 0 is just cosine of 1. And so this series converges to cosine of 1. That was squeeze theorem.